Air trapped in an airtight cylinder when the piston is 34 inches high is at 57 joules. How high must the piston be if the pressure is later at 115 joules? Okay, so what you've got to understand is that the height of the piston is standing in for the volume. Okay, I think we can agree if we have a piston, right, and we move inside a cylinder, right, if we move that piston, if it's a right circular cylinder, right, as I move this thing up and down, I directly affect the volume, okay? Didn't say it's a right circular cylinder. We need to say that, okay? But there it is. Okay, so that's going to stand in for my volume. This is my pressure, and this is a absolute pressure there, right? So this is going to be PV over NT. Pressure, temperature remains constant, and it's airtight, right? So PV over NT, PV over NT. NT stays the same, right? So P1 V1 is P2 V2. This makes it Bob's law. In all the names, I forget this is one of them. Okay, let's see. Okay, so pressure 1 is 57 joules, and our volume 1 is 34.1. Pressure 2 is 115 joules, and the height is the thing we're solving for. So I'm going to go 57 times 34.1 divided by 115, 16.9. Notice that this is inches, so this will end up being inches, right? Because the units all cancel out, right? All right, now let's do it. Let's woodshed this thing, right? Okay, we're trying to figure out the height of the piston, right? Okay, the thing that's going to change is the 34.1 inches, right? That's going to change, right? And let's think about this. If the pressure is increasing, doesn't it mean that the piston has been pushed down, right? So we want to take those two pressures and make this smaller, right? And the way to do that is to go 57 over 115, right? I want to make this smaller because I know the piston has to move down to get make the pressure higher. So 34.1 times 57 divided by 115 gives me the same answer, right? Okay. It's just a challenge. Okay, I'm assuming you know how to do this first, right?